Good afternoon. Today we're going to be talking about thin overlay mixtures. I don't think it's a real new topic anymore, but I want to give you some background real quick and where it came from, but mainly I want to talk about what the long-term performance has been over the last 8 to 9 years, any challenges that we have, and some new developments. In about 2007, the Austin District developed and constructed the first test sections in 2007. Our motivation was just to get a longer performance mixture than our dense graded mixtures that we're using for our overlay program. Also to enhance the safety aspect of it and of course to save money. In 2008, we led our first full-scale 1-inch thin overlays on I-35 and RM32. We began to implement a new high-friction surface course policy in 2008 at that time in the Austin District, trying to maximize our safety impact on our network. In 2012, we got a little braver and started developing a half-inch mix and did that first project on RM3238. And in 2015, we have done over 90 projects and saved about $26 million. The big question I get is how they're performing, and so we got to define performance first. First and foremost, the purpose of an overlay or the function of overlay is to restore the surface friction in order to have good skid resistance in wet weather. Durability, we typically define durability as far as rutting and cracking resistance. User satisfaction, ride quality, and noise reduction. Noise reduction is kind of a new measurable that we have these days. And of course, we want to have as long a service life as possible to get the best pavement preservation possible. So I haven't updated this data for this last year, but we're on the same trend, I can tell you. This is a database of all the thin overlays in our district. And so if y'all are so familiar with distress scores, it's basically a cumulative score of cracking and rutting and failures and patching and whatnot. And so anything above 70 is considered, above standard. And so we're well above standard, and we're still in the 90s, and we're headed to a trajectory to have, for most of our thin overlays, to have an 8 to 10 year performance period. If we look specifically at some projects, the first test section we ever did, we did a TOM in the northbound section and a traditional dense graded mix in the southbound direction. And as you can see there, we're still at a 93 on the distress score, and this is basically a 8-year-old project. And the dense graded mix has not fared up as well. RM32 is a thinner pavement, and it's continued to have great success and is still at 100%. And this is a thinner pavement, but it has a lot of truck traffic crossing from 281 to I-35. The I-35 project, which everybody's more familiar with, is a 13-mile project, basically 39 lane miles of thin overlay mixes. We went big on this one, and so we dove in. In 2008, we let that project, and as of right now, it still has a very good score of about 93% on distress score. This is the first year we have any type of major repair scheduled for it. We have some spot repair we're going to do out there, some isolated spots. And those spots basically are failing not due to the actually thin overlay. We have some stripping underneath it 2 to 3 inches down. So these are just areas we probably should have repaired before, but it's taken 8 years for it to manifest itself, which is pretty good. Noise is a big thing that we kind of backed into. We didn't intend for it to make a quiet pavement, but we did anyway, so sometimes you're better lucky than good. And so this is a RM12. This is the seal coat heard around the world in our district that everybody started losing sleep and their dogs started getting insomnia. And so we had to go overlay it because it was so noisy. And so lo and behold, we go through a thin overlay on this project and ends up being the quietest pavement we ever constructed in the state and measured at that point. And you can see the noise reduction on the right. This made a Napa magazine article on how we're trying to reduce noise pollution or noise reduction on our roadways, if you want to go look at that. More importantly, on the friction standpoint, the good thing about thin overlays is that it has a good microtexture, as you can see in the picture. These are Tom Scullion keys, so you can see you drive some type of Chevy, looks like. But this was part of a whole policy to go to high friction surface courses. We defined that as seal coats, thin overlays, PFCs, and SMAs, and concrete pavement surfaces. Big thing is we want to have good texture, and so the way we gap grade our thin overlays, we obtain that good macro texture, as you can see, and we do need durable and hard aggregates to sustain that over time. So this is kind of the historical trends of skid values. If you're also familiar with skid value, we measure the skid resistance of our whole network on an annual basis. In the Austin District, we do anywhere from 90 to 100%. And if you look at these different types of mixes, if you notice there's no values on this side because we can't really publish that. I just want to show the trend. So this is what we used to use with our dense graded mixtures, and you can see the relatively low skid levels as to our premium mixes, whether it be a PSC, a TOM, or SMA. But as you can see, all these thin overlay mixtures were pretty comparable with PSCs when it came down to skid numbers. And the good thing is they're sustainable, so they've kind of plateaued at a high level, and so that means we're going to get good skid properties and good skid performance over the length of its life. We wanted to see what effect that skid has on our system. These are actually wet weather skid database of ours that we did, and we plotted against our skid numbers values over time. And as one would conclude, the better skid values you had, the lower the crash rate would be. And so that really motivated us to really make that switch in 2008 to get high friction surface courses on the majority of our network. And as you can see, these are the overall average skid scores for our district. And as you can see, you can kind of tell when we did that. And we went full bore and we got 20% increase overall in our overall skid values for our district. The good thing, though, is that translated into lower crashes. And so this is the crash rate for wet weather crash rates and also wet weather fatality crash rates. And you can tell in 2008, you can see a slow decrease in those numbers. Considering that Austin is a metro district and we've had a sizable growth rate, and if you believe the daily vehicle miles growth rate, which I don't, because in most areas it's more like 8% in our area, the probability for wet weather crashes are higher, or any type of crash. But the trend is that they're actually going down. This isn't a unique idea. In Florida, they've gone almost holistically to open, to PFCs for their whole state, and they have some of the lowest crash rates in the nation. And so that's something we're trying to replicate in our district. Bottom line is we've seen dramatic, decreases in our crash rates, fatalities, and fatality rates. And whether you believe it or not, with all the noise and all the droughts and floods, we've had about the same average rainfall. All those numbers you saw were actually corrected and normalized for a normal rainfall year, so you don't see the dramatic changes from droughts and floods. So basically, we have seen sustainable friction over time, which is translated into lower crash rates. Our distress scores continue to be around 90% over 6 to 8 years now, and we've gotten good ride quality improvement and noise reduction. Some of the issues that we've gone into, I'm not going to be around for the Q&A, so I'm going to go a little into more details on maybe what some of the issues are. Some of the issues we have been going into in all our premium mixes that require modified asphalt is the presence of rehabs and PPA. As you can see, this was all paved within 3 months of each other, but the primary contractor couldn't, we made them go tear this lane out, redo it, but they couldn't get material, they couldn't get production, so they bought material from somebody else, and so this is a totally different asphalt supplier. Well, they've all aged for about 6 years, and you can see the difference in aging. This was actually 18 months after, no, about 2 years after compaction, or after construction. So you can see definitely that the rehabs and the PPA have a oxidation effect and a stiffening effect. And so when you're putting a lot of stress on such a thin layer and you're requiring the component parts to have high performance, this can be an issue. Aggregate supply, we are requiring a very durable, hard aggregate, so our soreness requirements are pretty low. And so this increases the demand for very premium aggregate. And so industry's been recalibrating their crushing fractions, and even with that, when we started in 2008, we were at about $5.50 a square yard. Now we're about, $6, $6.50. When you consider inflation, it's actually pretty much the same. And so we still have a significant cost savings relative to our old mixes. So this is our half-inch mix, this is our 1-inch mix. So a type D is fairly comparable to a 1-inch tom mix, but when you look over the performance period, you're going to be crack sealing this in 18 months, and you'll be crack sealing this in 8 years. And so the cost savings over the long term is much better with our thin overlay mixes. Bonding is probably the Achilles heel of a thin overlay. If you don't get good bonding, you're going to get this type of slippage that you see right here, especially at intersections or any type of turning movement. So it's really critical that we've gone exclusively to non-tracking tacks, which is fairly hard pin asphalts, and they give really good bonding strengths. The other thing is to make sure that if you have a milled surface or even existing surface, it has to be really clean. And this has probably been the biggest issues we've seen. This is a thin overlay mix right here, and all the tack is on the bottom of this and not on this. Big reason why is when they milled this surface, they really didn't sweep it very well. So it's just like rolling dough on a floured platforming and so it doesn't stick. And so we've actually we're developing a bonding core specification in our district in order to get a performance-based spec to make sure that we're getting that bonding, and hopefully we'll be coming with that soon. The other thing that's been emerging is the quality of the mill can affect the quality of the compaction of a thin overlay. And so we had this on an issue on an extreme project where they had no grade control, no laser, no skis or anything. So the milling was really rough. And so when you have that large a peak to valley milling surface, it gets really hard to start compacting such a harsh mix in those thicker and thinner areas. And so that really motivated us to adopt a version of Georgia DOT's micro milling spec. And so what this does, it requires a precision of about 1/16 of an inch, and these maximum spacings of the teeth. And so what this does basically gives you a profile mill. It's 12-foot drum, and it gives you a real small peak to valley and really good texture in which you can adhere a thin overlay and really eliminate a lot of the dirtiness and a lot of the compaction issues if you have a real bad milled surface. This is what it looks like when it's swept. If you read some of the literature from Georgia DOT, they have right specs on their milled surface. So for their micro milling, they have anywhere from 40 to 60 RRI requirements on it. So you can actually get most of your ride quality just out of the milling, and then whatever improvements you get from your thin overlay. I don't know how new these applications are. They're being fairly readily let these days. But we do have the new 1-inch PFC, which is basically a tom mix without screenings. So you have more than 20% air voids. You have this should be 1 1/4 inch SMAF, which Darlene's going to talk about. And of course, you have what used to be the ultra thin overlay, which is a 1/2 inch to 3/4 inch. This was the first 1/2 inch to 5/8 inch overlay we did in our district. This is what a typical paving train looks like with these dual rollers and the shuttle buggy and whatnot. And this thing still looks like, it looks like the first day we actually constructed it, and it did really well. The key with this one was we're really using this type of mix where we really need to restore friction. This roadway was actually in pretty good condition. It was an old Type C overlay that we had done about 2 to 3 years previous to overlaying it again, but it was really slick. And so we wanted to go out there and restore it. Given the number of subdivisions and population there and ADT there, seal coat probably would have been palatable. So we came up with this 1/2 inch version that's fairly cheap, but also offers the skid and the friction that it requires. So other people have kind of got in the wagon with us. This is Brownwood. They got real brave and put it on top of a bleeding seal coat on 84. And I talked to Eric at lunch, and he swears it still looks like what the first day they constructed it. And so it's done really well. It's a high truck traffic. So you can see how thin that really is. This is Odessa. They did a fine PFC on top of a bleeding seal coat. And then I think Casey keeps on telling me it's doing fine. We've done 2 PFCs now, thin PFCs. We did our first on the interstate this last year, and it's doing really well. This one made me nervous when we first came out with it because they're putting it on top of concrete pavement with a cam mix with a 1-inch tom on top. And I thought, that's a whole lot of asphalt on top of a very stiff layer. And so, but it did great. I keep on hearing great things about it. If you can see the ADT on here, I mean, that's some major traffic in downtown Houston. Actually won an award this last year at Texapa